If you've ever wondered how to take a Kubernetes cluster and turn it into a platform that can manage applications from Git, this is where Argo CD comes in. In this walkthrough, we're going to install Argo CD into a Kubernetes environment, verify that all of its components are running, retrieve the initial administrator credentials, connect through the Argo CD command line, and then use the Argo CD web interface to create and synchronize an application from a Git repository. The important idea is GitOps. Instead of manually changing application resources inside the cluster, we can keep the desired configuration in Git and let Argo CD continuously compare that configuration with what's actually running in Kubernetes. So let's start from the project and work our way through the entire process. Before installing anything, the project documentation lays out the basic prerequisites. We need a working Kubernetes cluster, and we need access to a Git repository that will hold the application configuration. This is an important starting point because Argo CD doesn't replace Kubernetes. Argo CD runs inside Kubernetes and uses Kubernetes as the platform where applications are deployed. The Git repository becomes the source of truth for what we want the application environment to look like. On screen, we're reviewing the installation documentation and the project structure. The goal is to make the installation repeatable rather than relying on a collection of commands that only exist in someone's terminal history. That is one of the recurring themes in DevOps. Document the process, automate the repetitive work, and keep the desired state somewhere that can be reviewed and versioned. Now we're moving into the terminal. The repository contains an installation script, so instead of manually entering every Argo CD installation command, we're going to use that script to apply the required resources to the cluster. The script is responsible for getting Argo CD installed and configured in the Kubernetes environment. As the command runs, Kubernetes begins creating the resources that Argo CD needs. This includes the Argo CD server and the controllers and supporting services that make up the platform. At this point, it's worth remembering that an installation command finishing doesn't automatically mean the application is ready. Kubernetes is asynchronous. Resources can be created before the containers inside them are fully started. That's why the next step is verification. We're going to check the Argo CD namespace and watch the pods come up. Here we can see the different Argo CD components being reported by Kubernetes. The application controller is responsible for managing application state. The repository server handles communication with Git repositories and works with application manifests. The API server provides the interface used by the CLI and web interface. Other supporting components handle notifications, caching, and internal services. The exact architecture can evolve between releases, but the important concept is that Argo CD is itself a collection of Kubernetes workloads. Once those pods report as ready and running, we have a good indication that the installation completed successfully. We're also checking the services that Argo CD created. This is another useful troubleshooting habit. When something isn't accessible, don't only check the pod, check the service, the endpoints, the ports, and the way traffic is exposed. In this environment, the Argo CD server is exposed so that we can reach the web interface and the API from outside the cluster. Now that the components are running, we need the initial administrator password. Argo CD stores the initial administrator credential as a Kubernetes secret. The command shown here retrieves that secret and decodes the password so it can be used for the first login. This password should be treated as a temporary administrative credential. Don't publish it, don't commit it to Git, and don't reuse it as a permanent secret. Once the initial login has been completed, a production environment should use an appropriate identity and access strategy rather than relying on the initial bootstrap credential. Next, we're configuring the Argo CD command line interface. The CLI gives us another way to interact with Argo CD without relying entirely on the browser. This is particularly useful for automation and for scripting repetitive administrative tasks. After the CLI is available, we connect it to the Argo CD server and authenticate using the administrator account. Once the login succeeds, the command line becomes another control surface for the GitOps platform. Now let's talk about the part that makes Argo CD especially useful, the Git repository. Instead of manually applying Kubernetes manifests every time an application changes, we can keep those manifests or Helm configuration in Git. A change is committed to the repository, Argo CD detects the difference, and the application can be synchronized so that the cluster moves toward the state defined in Git. This creates a much clearer workflow. Git becomes the place where we review configuration changes, pull requests can be used for collaboration, Git history gives us an audit trail, and Argo CD becomes the component that continuously reconciles the cluster with the desired state. On screen, we're looking at the project documentation and the Git repository structure that will be used by Argo CD. Now we're moving into the Argo CD web interface. At first, the applications page is empty. That's expected. Installing Argo CD gives us the platform, but it doesn't automatically know which applications we want it to manage. We're going to create an application. The first part of the application configuration identifies the application itself and the Argo CD project it belongs to. Then we define the synchronization policy. This is where GitOps starts becoming visible in the configuration. We can choose whether synchronization happens manually or automatically, and we can define additional behaviors such as pruning resources that are no longer part of the desired configuration. These settings should be chosen carefully in a production environment because synchronization policies determine how aggressively Argo CD changes the cluster. Next, we define the source. The source tells Argo CD where the desired application configuration lives. In this walkthrough, the source is a Git repository. We provide the repository address, choose the desired revision, and specify the path inside the repository where the application configuration can be found. This separation between source and destination is one of the most important concepts in Argo CD. The source describes what we want. The destination describes where we want it. For the destination, we're pointing Argo CD at the Kubernetes cluster and namespace where the application should be deployed. In this example, the application is configured for a Kubernetes namespace associated with the workload. Once the source and destination are defined, Argo CD has enough information to understand the application relationship between Git and Kubernetes. Now we create the application. Argo CD begins evaluating the repository and comparing the desired resources with what's currently present in the cluster. At this point, the application can show a status such as progressing, synced, or out of sync depending on what Argo CD finds. If the repository contains resources that aren't currently deployed, Argo CD can synchronize those resources into the cluster, and that's the core GitOps loop. Git contains the desired state. Argo CD observes the desired state. Kubernetes contains the live state. Argo CD compares the two and works to reconcile them. We're now watching that process from the terminal as well. These commands show the application resources appearing in the target namespace. We can see the pod, service, and deployment being created and moving toward a ready state. This is an important verification step because it confirms that the Argo CD application isn't just configured in the UI. The configuration is actually producing Kubernetes resources. Once the workload is running, we can return to the Argo CD interface and see the application represented there. The application view gives us a visual representation of the resources that Argo CD is managing. Instead of jumping between several kubectl commands, we can see the application, its synchronization status, and the resources associated with it in one place. This becomes especially valuable as the environment grows. Imagine managing dozens or hundreds of applications. Manually tracking every deployment and checking every namespace would quickly become difficult. Argo CD gives teams a central GitOps control plane for those applications. There's also an important operational benefit here: visibility. If someone changes a resource directly in Kubernetes and that change doesn't match what's in Git, Argo CD can identify the difference. That means configuration drift becomes something we can detect instead of something we discover later during an incident. And this is where GitOps connects directly with security and operational discipline. We want infrastructure and application changes to be reviewable, traceable, and repeatable. Git provides the history. Argo CD provides reconciliation. Kubernetes provides the runtime platform. Together, those pieces create a much more controlled deployment workflow. Now let's look at the final state. The Argo CD interface is available. The application has been defined. The Git repository is configured as the source. The Kubernetes cluster is configured as the destination. And the workload has been synchronized into the target namespace. The terminal verification confirms that the expected Kubernetes resources are running. Means we've successfully moved from installing the GitOps platform to actually using it to manage an application. And that's the key distinction. Installing Argo CD is only the beginning. The real value comes from connecting it to Git and using reconciliation to keep Kubernetes aligned with the desired state. So let's summarize what we accomplished. We started with the documented prerequisites and project structure. We ran the Argo CD installation process inside the Kubernetes environment. We verified the Argo CD pods and services, received the initial administrator credential. We configured the Argo CD CLI and authenticated to the server. Then we opened the Argo CD web interface and created an application using a Git repository as the source and Kubernetes as the destination. Finally, we synchronized the application and verified the resulting Kubernetes resources. The basic GitOps workflow in action. And once you understand this workflow, you can start building more advanced deployment pipelines around it, including automated synchronization, Helm-based applications, policy enforcement, security controls, and multi-environment deployments. If you're learning Kubernetes, DevOps, GitOps, or cloud-native infrastructure, Argo CD is one of the tools worth understanding because it changes the way applications are delivered and managed. Instead of asking, what commands do I need to run on the cluster, the better question becomes, what should the desired state be, and where is that state defined? When Git becomes the source of truth and Argo CD continuously reconciles that state, deployment becomes a process instead of a collection of manual commands. And that's the real power of GitOps. If you found this walkthrough useful, subscribe to Tech Shorts for more hands-on Kubernetes, cloud, DevOps, automation, and security content. Tech made simple, sound made memorable, and infrastructure you can actually understand.